Now that we've learned how to calculate molarity, we're going to learn how to make solutions in lab. And this is what I do when I'm trying to make solutions for our different experiments. We're on interactive notebook page 4, and we're going to be on the back of our molarity calculations worksheet. And it looks like this. And it says at the top, I've written in there to remind you to check charges. There are problems 10 through 18 on the back. We're going to be looking at 3 of those. We're going to look at 13, 16, and 18. So just as a review, we know that molarity is a measure of concentration, and we know the equation for molarity is moles of solute divided by liters of solution. So it's basically just telling us how much solute do we have in relation to the entire solution. We also learned how to use our T box, which is capital M for molarity, moles divided by liters. Okay, so the problem asks us on our worksheet to explain how you would make the following solutions and to tell how many grams of the substance we need to make the solution. So we're going to need to be finding grams. Well, when I look at my box for my calculations, I don't have anything for grams, but I do have something very closely related to grams. I have moles. So in order to find the moles, which will give me the grams, I cover up moles, and I'm going to be using molarity times liters. So I'm going to use that from my equation. Molarity times liters, and then I can turn it into grams. So I have 45 milliliters of a 0.12 molar solution. Well, I know that I said that it was going to be moles times liters is going to give me, molarity times liters is going to give me moles. So for molarity, I have 0.12 molarity, which is really just saying moles over liters, times liters. Now, I've been given 45 milliliters. Well, I learned that if I divide milliliters by 1,000, I'm going to get liters. So 45 divided by 1,000 gives me 0.045, 0.045 liters. So I take 0.12 molarity times 0.045 liters. Now, I changed this molarity, or M, into moles over liters so that you could see something. Whenever I multiply this, my liters are top and bottom, so they'll cancel, leaving me with moles, which is what I wanted. So I just wanted you to be able to see that. Okay, so 0.12 times 0.045 gives me 0.0054 moles of sodium carbonate is how much I'm going to need to weigh out in the lab. But my scale doesn't measure in moles. My scale does measure in grams. So I'm going to need to turn this mole answer into grams. And in order to do that, I have to know what sodium carbonate is. So I'm going to look on my periodic table, and I'm going to find that sodium is Na plus 1, and carbonate is CO3 minus 2. Well, in order for Na plus 1 and CO3 minus 2 to cancel, I'm going to need another Na, so that plus 1 and negative 2 cancel out or neutralize to 0. So I know that my formula is going to be Na2CO3. Na2CO3. So I have 0.0054 moles of Na2CO3, and I need to turn that into grams. So 1 mole will come to the bottom, and grams of Na2CO3 will go on top. Na2CO3. Well, I know in order to get that, I'm going to have to take Na times 2, so 22.9 times 2, plus carbon, which is 12.01, plus oxygen times 3. So I put that in parentheses in my calculator, and then I get 105.7. We're just going to write 106 down. So 105.7 times 0.0054 gives me 0.57 grams. So I'm going to need 0.57 grams of Na2CO3. This isn't really an answer though. This just tells me how many grams I need. It doesn't tell me how to make the solution. I have to write this answer as a statement, so I'm going to write it over here since I've run out of room. I would put 0.57 grams of Na2CO3 in a beaker, and then once that's in the beaker, I'm going to add water up to 45 milliliters. Dilute up to 45 milliliters. It's really important that we understand that we dilute up to 45 milliliters. And that comes back to the idea that it is liters of solution. Solution means the solute and the solvent, water, together. So we have to put our solute in first and then dilute up to the 45 milliliter mark. instead of filling it with 45 milliliters and then adding the salt, because then we would be above our liter concentration and we'd have a different concentration. So our actual answer is this sentence here. Put the grams of Na2CO3 in a beaker and then dilute up to the volume that they asked for. So let's try another problem. Let's try number 16. 16 says 6.7 liters of a 4.5 molar ammonium nitrate. Again, I know in order to do it in lab, I'm going to have it in grams. So moles, molarity, and liters. I've been given liters and I've been given molarity. So 4.5 moles times 6.7 liters equals 4.5 times 6.7 equals 30.15. 30.15, and I know that this is really moles over liters, so my liters cancel, leaving me with moles of ammonium nitrate. Well, I'm going to have to deal with ammonium nitrate. Ammonium is NH4 plus 1, it's on the back of my periodic table, and nitrate is NO3 negative 1. Well, NH4 plus 1 and NO3 negative 1 cancel, and so I just get NH4 NO3, NH4 NO3, but that's in moles. I have to turn it into grams. So I know that 1 mole is going to equal the mass on the periodic table for NH4 NO3. So I have to add those together. N is 14.007 plus H, which is 1.007 times 4, and I put that in parentheses in my calculator, plus N, 14.007, plus 15.99 times 3, again in parentheses in my calculator. And I get 80 grams as my answer. So 80 grams is in 1 mole for NH4NO3. I take 80 times 30.15, and I get 2,412. 2,412 grams. Now I want to go back and double check because that seems like a really high number. So I'm going to take 4.5 times 6.7, and I got 30.15. And then I know that 15.99 times 3 plus 1.007 times 4 plus 14.007 times 2 did equal 80. So 80 times 30.15 is 2412. So that's the correct answer. Anytime an answer looks off, I'm going to go back and check my math. So I know that I'm going to need 2,412 grams of NH4NO3. But again, I have to write my statement, so I'm going to put this in the beaker. I'm going to put 2412 grams of NH4NO3 in the beaker, and I will dilute up to my desired volume, dilute up to 6.7 liters. And that would be my answer, because again, I'm asking how do I make the solution in lab? Okay, last example problem for this set. 90 milliliters of a 1.2 molar solution. So molarity, moles, and liters. I know I'm going to take moles and turn it into grams. So I take molarity times liters. Molarity is 1.2 times 90 milliliters. Now remember, we've talked about that. 90 divided by 1,000 gives me 0.09. So that's 0.09 liters, because I had to turn milliliters into liters by dividing by 1,000. And so 0.09 times 1.2 gives me a mole number of 0.108 moles. And remember, because molarity is moles over liters, the liters cancel, leaving me with moles. Okay, and I have to turn this into grams. Well, I've already been given the formula, which is nice. So we know that 1 mole equals the grams of BF3. I don't have to check the charges like I did here because they've already given me the formula. The charges are already balanced. So F on the periodic table is 18.99 times 3 plus B, which is 10.8. And so that gives me a mass for BF3 of 67.8. So 67.8 times 0.108 equals 7.3 grams. So again, I'm going to write my sentence. 7.3 grams put 7.3 grams of BF3 in a beaker, and then dilute up to the 90 milliliter mark. Now you could have also written dilute up to the 0.09 liter mark, and you would have been correct. So let's just review. In order to tell me how to make solutions in the lab, you must give me the actual directions, and the directions require grams. So you used molarity and the volume that they wanted to get moles. We turned moles into grams using the mass on the periodic table, and then we wrote our statement. Our statement was to put the desired value of grams into a beaker and dilute up to whatever they wanted. For 13, we had to dilute up to 45. For 16, we had to dilute to 6.7. And for 18, we had to dilute up to 90. We also said that it's okay if you leave it in milliliters, or you could convert it into liters for your answer. Either one is fine.